So hello and welcome to another edition of High Tech Connect, our interview series today with Gabriele Scheler on where do we actually stand with the current AI, particularly the large language models that everyone is so excited about, the technologies, and even more important, what comes after all this. So that will be our topic today. Hello, Gabriele. Nice to have you today. How are you?
Fine, I'm okay.
Great. So please introduce your professional career to us. You are living in Europe right now, but
Yes,
you
I'm
have,
in Europe right now, since the
yeah.
pandemic actually, but I still maintain an office in Mountain View. And I have a background, I'm German, I have a background growing up in Göttingen, a university town. And I always wanted to be a scientist. And already as a teenager, I thought what I want to discover is actually how we think. So how do humans think? That's really seemed like a big mystery to me, how this is mechanically possible or understandable. And so I embarked on a journey of different universities. I actually spent some time at one of the first AI groups in Munich, together with Jürgen Schmidhuber and Sepp Hochreiter. And then I was at the Salk Institute in the US, where I began to study neurobiology. So it occurred to me that even though it seems like a stretch, in order to understand how humans think, we need to get into the brain and understand the brain. Up to that point, I had mainly done natural language processing, linguistics, logic, and also, as I said, AI. And now at this point, a couple of years ago, I've decided to apply what we know into functional models in order to finally solve or at least provide a functional solution to the problem of human thought, verbal thought, but not necessarily only verbal thought. Still, that is the goal, to understand how we think in words, how we form sentences, how these sentences come to our head, how we move from one thought to the other, how we integrate thoughts, how we reason, plan, decide. And so it's obviously very closely related to modern LLMs and modern AI, generative AI.
Right. Great. Yeah. So let's continue here. So yeah, we had a real success story when these large language models came out with ChatGPT, and now many others got huge amount of fundings. But you can also read among the expert community that we actually have reached with this the end of a technical path. And can you explain a little bit? First of all, do you share this opinion and explain a little bit why this is actually now pretty much a dead end, and we will not
I would essentially
much
agree
further.
from the technological point of view. We have reached an end because we have done this data analysis and statistics under the name of neural networks for 20 to 30 years. And during this time, the amount of data and the processing power increased all the time, exponentially, enormously. And so the successes that we seem to have had were not necessarily in terms of technological breakthroughs, but in terms of applications, ever bigger applications, ever more impressive applications. And I think we have reached an endpoint, especially since these models become exponentially large, exponentially expensive. They use huge amounts of electricity and so on. And what developments we have had in terms of generative AI, there was this idea of doing longer context embeddings. We used to have recurrent networks and the LSTM networks, which you had. And when Hochreiter says he can do the same thing when an LSTM, which you can do with several attention heads and a transformer network, that makes sense. Because it is essentially the same task and a similar architecture. So we are not looking at technological advance. We are only looking at something that is amazing or surprising, how much this was be able to be scaled, how large networks we have. But we have lots of problems, of course, with statistical analysis because it's never precise. It has all these bugs and only 80% correct and so on. So many uses where you would not want to use a statistical model at all. You don't want it in safety critical applications. You don't really want it in medicine or health. You can use it for consumer data in business applications and you can, in general, I would say you can use it for a quick and dirty solution. But if you want to implement a model that works and that is reliable, then this is not a technology that's further. You cannot further go on this technology. You have to go back and say we need to do something else.
Right. And you say you're on a different path. You want to do something else. Can you give us a quick intro and a general explanation what this means and how do you believe can this?
I mean, I can do this too, but before I do this, I would say from my perspective, from the, let's say, technological business and so on perspective, what we do is not ripe, so to speak. What I would suggest in the meantime, what will probably happen is something like a hybrid models. So these are models that incorporate logical relationships. There are models which connect knowledge graphs, which are essentially logical models with large language models. So in this area, there is a lot of room for improvement to simply combine classical symbolic AI, logic, theorem proving, actual inferences, and so on with these statistical models. There are several approaches and already a few companies which follow up on this. I think this will be probably expensive and a bit difficult, but if it's well done and curated, could be for the foreseeable future a good solution. Now, in terms of what we do or what we try to do, that's as I said, it's in a different on a different plane because I'm essentially a scientist. So I'm essentially, as I said, interested in solving or understanding nature. In this case, neuroscience. And so our goal is to finally get a functional model. So we have lots and lots of models of the brain that people work with all the time. But these models are made, they are simulation models. You cannot actually use them, or you don't want to use them for a functional task, for a computational task. They are brittle. They break apart. They constantly have to tune them or something or other. And so a few people, not very many, try to sort of solve the brain and find functional models which are actually applicable. Because what we have in these statistical, I call them statistical data analysts, I could call them brain-inspired or neural networks, but they rely on neuroscience from the 1950s. That is simply the case. And we have lots and lots more. We know that neurons are actually biological cells. They have a lot of internal computation, protein interactions, genetic networks, and so on. So we don't lack information, but we lack sort of integration or overview, a theory. And this is where we hope to do our first commercial application, to offer a platform for using an enhanced brain model to solve certain functions. And one of the applications would certainly be in the area of robotics. And decision-making, planning, and so on. So this will take at least a year before we will have something like a prototype.
Let's dive into this, but before we do this, I'd like to ask you a couple agree, disagree questions. I think people like to hear from an expert these always the same more or less questions, but I ask you them as well. So, for example, one common question is that AGI or actually claims by the current large language model players, it says AGI is close with the current LLMs. Agree, disagree?
I disagree. No, it's no way, it has nothing to do with intelligence. I said even Wikipedia is closer.
Okay,
Because you have
good. Yeah.
lots of information, you yourself have to interpret it. So there's not such a big difference.
Yeah. Then there was the other side, the doomsayers. They say that danger is real and the current AI is really threatening and humanity is doomed. What do you say to them?
Yeah, I thought about this too. And the answer from my perspective is it is dangerous if you put it in weapons, in autonomous vehicles, in all kinds of things that can be used as weapons in war scenarios. If you use this to decide on war-related questions and so on, it depends on the context. If you put it in a caring context, in a senior home or something, then it's not dangerous. It
I
depends.
see. Okay.
But the danger is real because there's a lot of military applications to it.
Mhm. Okay. Then another thing that we are confronted with since many years, in fact, and we expected to be here now, but it doesn't seem to be here, is our self-driving cars. Do you expect them to be here in the next, let's say, be another 5 years or so, or will this never happen? And just
Well, I haven't been in one myself, but as far as I know, they drive around San Francisco right now, and they were working more or less. And my take has always been in a controlled environment, that's fine. But they cannot duplicate humans in highly uncontrolled environments.
Okay. So there's certain levels to it. Level 5 would be full full driving capability that you don't see coming.
Actually, I think these levels are not quite correct. I mean, they started way back in the desert with self-driving cars, and there was the Stanley car from Stanford, which won, and they were already driving on their own. And so I think it's not that capability, it's a capability of understanding a situation that you're in, and that a self-driving car cannot fully do. But if you put it in a controlled environment, as I said, or like just without any, there are such scenarios where it doesn't have to make decisions and of a complex kind, then you can have drive all on its own.
Another thing that's mentioned on the threat side is that the AI is costing us lots and lots of jobs and ultimately will be a big societal problem, right? I mean, if you don't have jobs for people anymore and this is automated, then yeah, there will be a huge issue for many. What do you think about it?
Just the same. I mean, these are, of course not. We will have new jobs. We have to service all this AI. But there are always structural problems in the economy. That is not so much a question. Could happen. But in general, of course, no, we will have more jobs.
Okay. And then something where Europe is famous for is the regulation of things. Now they have regulated AI as well. But in the US, they had a different approach. Um, they were discussing or are discussing that they regulate themselves. What do you think about maybe two questions? The AI regulations in Europe, is this going too far, or you think that's needed? And then the other one in the US, where they discuss that they regulate themselves. It's not decided, of course, but it's
Yeah.
they definitely discuss it. Yeah.
So actually, I have to admit, I haven't really read up or followed up about the EU regulations, what they contain. In general, of course, like everything, the government has to regulate industry. That's normal. I think the EU was strangely fast, and I don't think any of the people had any idea what they were talking about. So maybe that was not a very wise move. But in general, the idea of industry regulating itself, I'm certainly opposed to that. But one has to take a little bit more time, certainly, to find out where we need to draw the lines.
Okay. So last question on this one, and bridging towards your topic, there is another Elon Musk company, Neuralink. You think what they're doing is useful and will lead to useful applications? It looks quite scary to drill a hole in your brain, so to me.
So as far as I know, they are firmly on the invasive side. So I think invasive brain computer technology interfaces could be very useful for disease, for people with neurological diseases and so on, but they are not for consumers. Opening the skull is always dangerous. and it's not something that will take on for regular people. Different
Right.
is when you have the non-invasive parts like EEG and so on. That's a different question. But Neuralink, to my knowledge, they're trying to go the invasive.
All right.
And if this helps, is this helpful for people that somebody like Elon Musk invests money? I'm for it. As far as I know, the Neuralink company has not the best reputation in terms of this kind of research, because there are others and they have more experience and more knowledge in terms of what they did with apes, or monkeys rather, before. There's many problems with how the brain, after all, it's neural tissue, it's living tissue, reacts to it and so on. So I have not a good opinion of Neuralink.
Mhm. All right, so back to your topic, research and applications. You mentioned already in the introduction that you're looking at a symbol producing machine, so the cortex, right? The pre-structured cortex. Can you explain for the layman and woman what is a symbol producing machine? What are symbols in, I mean, what you're talking about and in comparison to also
Yeah,
what we
well,
have
I mean,
now?
this is one of the things that came up in our research, because you have, of course, many aspects. But I thought one thing we could focus on is the idea that in our brain we produce symbols as crisp computation, so we don't have feature clouds, point clouds, or things like that we need to work with. As I said, I want to get rid of statistics and vagueness in computation. And once we have that kind of model available based on neural procedures, we can then do lots of computations which are reliable and which are transparent, and which would allow us to employ the actual advantages
Mm.
of using computers, of computation. The point of computers is that from the hardware point of view, try to make them as exact and as precise as possible. And then if you're on the software side, suddenly are not interested in that anymore. We could as well have, I mean, NVIDIA could sell tons of buggy chips and nobody would notice, because these models are buggy. So who would know that the chips are buggy? So I'm thinking differently about computation and about the advantages of using computers, which is that they help you be more precise. So we humans are able to have to do mathematics. We are able to prove theorems. We are able to follow logic and to have arguments. Sometimes I quote Leibniz, the German philosopher, who already in I think the 17th century said what he dreams of is when people have an argument that they could sit down and say calculemos. So it's Latin for saying let us calculate, let us compute.
Mm-hmm.
This is how we solve problems. And this is, I think, what our computers can do and what we would want them to do in AI.
Mm-hmm. Let's go back to your explanation, because I must admit I still didn't fully get it. Of course, I'm not like most people who are watching this, a neuroscientist at all, coming from the computer science and electrical engineering side. So yeah, I learned data science and statistics. What you think is now at the end. So I need to learn new things. So, but explain to me and the audience a bit more, please. So how does this practically look like, right? I mean, you try to simulate and find out how the brain works, and let's say you understand how it works, and so how would you then concretely apply this to solve problems at the end? You know, if you want to make it accessible for humans, it's and get it out of research, then you know it needs to solve some problems and serve some applications. How would both look like, and how would this be connected? Can you a bit more concretely explain this, please?
Yeah, well, actually, first I have to say, I do not think that data analysis or statistics as such will ever end. We will always need it. But I'm just in terms of AI, in terms of
Glad to hear
developing
that.
intelligence, that's where we are sort of have reached the point where we can do pattern recognition, which is essentially perception.
Mm-hmm.
But our minds and brains do not stop at perception, but the next step is cognition. And that means that on the basis, on the basis we have pre-structured brains, which have the capability of producing certain outcomes from this environments. And so they are not blank slates. They are not empty networks. They are not universal function approximators. So as you know, a neural network is essentially a universal function approximator.
Right.
And that as such, there are several, and they are all logically related. And so a lot of development, for instance, deep learning, is essentially just a question of better efficiency. Because if you have a network with many layers, it is nothing else but one hidden layer. So you can compress it and you have one hidden layer, which is very large, and you have the same logical or mathematical capability as a deep layer network.
But deep neural networks are often explained as with the human brain cell, right? We have input and then it fires with the activation function, right? If it's strong enough, and then you have output and then non-linear activation function to make any sense. And then of course you have the back propagation to then learn and calculate the new weights. But they always mirror this as a neural network. Neural is the word neural in it. So, but you're saying that has actually nothing to do with how the brain works. Is that right? Or
let's say it's a
part of it?
very, very superficial abstraction.
Right.
And there's lots of aspects missing. One of them, as I said, is that what we find in nature is that these networks are pre-structured. They have a structure which makes them inclined to construct certain, as I said, crisp symbols, for instance. That's inbuilt. And then secondly, as I said, the neurons are cells. They have an internal computation. They are processors as such. And so you can store memory inside a neuron. So the idea that all the memory is in the weights between the neurons is simplistic. And it leads to all kinds of problems, because if you think about it, the problem has been that if you do it that way, then how can you have long-term memory? How can you make sure that when you have, for instance, a time series, that the later points in the time series do not override the earlier parts, since you have no independent memory, so it's always overwritten. And there was a solutions, as I said, this very early solution about yes, Buchreiter and so on. And what he actually did was he took a couple of neurons together and built a particular unit so that the memory could be stored in this small unit and be read out when needed. And in reality, we have a neuron, and the neuron does have an internal processing module. And it actually the case that we know that receptors on the surface of the neuron, they are stimulated, and they can put signals inside, and these signals can be read out. So it's exactly this model that you have an outer part of the neuron that's sort of the information that's being processed right now, and then we have an inner part which is stored for and is read out in certain situations. And then we have, this is the recurrent model, which this is based on. And then we have the other solution, which is this attention head, or rather this is embeddings solution, where you have very, very long contexts. And then you want to be able to sort of, with this attention head, find spaces in this very long context where you make the connection to the current information. And as you know, there has been a development where they simply used longer and longer contexts, and the models became more and more precise. They have essentially a next word prediction. And in order to predict the next word, if you have a context window that goes back like 100 tokens, that's not good enough. So they have now token windows where you can use the whole article. And so we have the next word prediction. Basically, we are storing the article verbatim. And this is another attempt from these kinds of models to solve an issue that is inbuilt in them. And I consider this sort of the wrong model. What we do in the brain, how our memory doesn't work sequential at all. We store memory in places, in different places, and we access it according to content. So we don't have this kind of sequential memory. And how is this achieved? I think a very significant or decisive part is this insight that we have knowledge, or rather memory, that is accessible to processing, and memory that has to be stimulated in order to become accessible. And so this is a decisive part of our model, and this is something I actually already wrote a paper about, because it seemed so important to me to lead people away from the idea that all the memory must be stored in weights between neurons, and of which the function itself doesn't matter.
How far would your approach, if you can pull it off, bring us then? It would basically then give us applications that are highly accurate and not hallucinating, for example.
Yeah. Well, my
you
take
can
is,
use it for planning and mission
I have
critical
to be,
things. No,
I'm not in Silicon Valley right now, so I don't have this rule the world kind of phenomenon. So my take is simpler. As I said, the first step is to provide a platform with the necessary parts to build algorithms and applications for it with some demos. And the second part, of course, is already the question of getting the investors, the funding, and everything like that, is of course to actually build solutions then for partners. But that will be the second part, and I think already not so much my personal interest anymore. But of course, I hope to lead it to this. And in the meantime, I would hope that people will use what we have and start building themselves. Yeah.
And when you talk about your platform, that of course requires some compute platform as well. You also need lots and lots of misused graphical processors, or your compute requirements are much lower. Can you give an idea about that, please?
Yeah, well, I mean, that's exactly the same thing. It's a question of scaling. You don't have to start with a huge model in this case, because we are not competing, or I'm not competing with the LLM model right away. This is essentially, as I said, what we had in neural networks in the early days. This is just a model that runs on AVS or something, and where you can build models of different sizes. And as I said, I would be interested to see the industry application to it at some point, and where all these questions need to be decided when we need really the right kind of funding for it. But before we have an industry size application set and actual, partners who use it in their problem solving, we want to be able to spread that out to the community and get feedback from them, see what kind of traction we get. That is a very interesting question.
Right.
It could be that people take it up, or that it requires a lot of propaganda in order to ask people to take it up, sort of.
Let's call it marketing for once.
Yeah, it's not
same.
clear whether people flock to it or whether people don't see the value.
Yeah. So, but still, what type of applications do you foresee in the next couple of years possible, assuming, there is funding, there's interest, you assemble everything that's needed. But what can be done with that in your imagination and expectation? Yeah.
So I'm very interested in the fields of decision making and planning. Planning and subgoals and so on. I have a background, of course, in linguistics, in language processing. I did that for like 10 years or so earlier on in my life, so that it's natural to me. I have no understanding and interest myself in vision. So again, this is something, once you get to the application area, there could be an enhancement in terms of the kind of problems that other people would bring to the table. And but I think that is a very important scenario, as I said, because it needs to be transparent and it needs to be oriented for actually logical and theory improving and rule following, if you want to, and still be. And I said I see it also very interesting to be in a robotic environment.
Okay.
Because this is something that people have lots of problems with right now. That on the one hand, well, let's not go too much into robotics. I'm not an expert on robotics. I just talk to people about it. But as I said, decision-making, planning, that kind of, as I said, thinking. That's really what it is.
Great. So if someone wants to, first of all, I think we will spread definitely your paper that you mentioned, so people can read that. Is there other information out there already? Like I didn't really find any books on this, but I'm sure there are, or any conferences or something
I
where
mean, this is
can
still an
inform
area. That's why,
themselves if they're not familiar with your topic but interested.
yeah, as I said, this is an area, actually, that's what I said. That's why I like it so much. It's not crystallized yet. There are different people who have different ideas about it. And so it's still very creative and evolving. And what I could mention for people who are interested, there are at least 2 conferences, like there's the CNS conference and the Cosine conference, and they have proceedings, of course, and they do exactly this. They do theoretical neuroscience and try to use results from experimental neuroscience in order to come up with theoretical functional models of what the brain does. I think that would be the best way for people to get involved in this, because that's always current and topical. You know, they have a conference every year.
Okay. Great. Thanks so much. So you're living at the moment, well, you were born in Germany, then studied in Munich, then went to the US, but currently you are in Southern Europe somewhere, where it's also warmer than here in Switzerland right now, for example. But of course, you are business-wise, research-wise in the US. So are you more European or American now? And where will you retire at some point? Maybe to close with that question. So,
well, I've always been, as a person, I mean, certainly European, but in terms of my work, I've always been US-centric. I have not been happy in Europe for a couple of reasons. I've been felt very much. Also, I have to say, since I'm a woman, as a female, you are more accepted in the US than you are in France, especially in Germany. So that was a relief for me when I went to the US. I thought, oh, normal person suddenly. I'm not an outsider anymore.
okay.
And so in work terms, I like the US much better, and especially Silicon Valley. And with this new approach, we will see when I will return. I'm not quite sure, maybe this year.
Okay. Cool. Thanks so much. You have a great day. And yeah, looking forward that your research is getting into the real world and creates fantastic applications that make our life easier and improve where we are right now with the large language models, of course. Right. So,
Okay.
thank you. Bye-bye. Cheers.
Thank you.
Thanks.